Chapter 1, Pangea. At one point in time, the continent of the world were molded into one to form the supercontinent known as Pangea. Pangea consisted of 7 mainland masses of today, known as Eurasia, North America, South America, Africa, Antarctica, India, and Australia. We have scientific proof this has happened because fossils found in one landmass can be traced to all others, and the physical coastlines of said landmasses, so on and so forth. This process of continental drift led to the formation of our present-day world. As the plates slide around and smash into each other, they create different faults. One of these faults is a convergent fault, which occurs when 2 plates collide into each other, usually resulting in mountains and volcanoes. Another type would be a divergent fault, where 2 plates move away from each other, which can create a trench. The final fault would be a transform fault, where 2 plates rub against each other, shaking the ground, which create earthquakes. Chapter 2, Seafloor Spreading. Seafloor spreading occurs where oceanic plates are diverging from one another. Magma rises along a rift zone and spreads out at the surface, building new seafloor. As a result, the age of the rocks increase as one moves away from the rift zone. The mid-oceanic ridge is a primary site for seafloor spreading. Earthquakes and volcanoes are where seafloor spreading is occurring. Seafloor spreading helps explain continental drift in the theory of plate tectonics. At the mid-Atlantic ridge, material from the upper mantle rises through the faults between the oceanic plates to form new crust as the plates move away from each other, a phenomenon first observed as continental drift. Since then, it has been shown that the motion of the continents is linked to seafloor spreading. Chapter 3, Gravitational Force and Thermal Energy Transfer. Every object has gravity. One of the characteristics of a planet is that it has enough gravity to be able to smooth out a lot of the irregularities on the planet's surface, allowing the planet to take on a round or oval shape. So that's the key way that gravity affects the Earth. If, for instance, the Earth's gravity was half of what it is now, there would be a lot more rigid bodies on the surface of Earth, since gravity would not be pulling as hard to flatten them out. Mountains would be able to reach higher heights, and their incline would be much steeper. Gravity affects Earth's surface by trying to pull everything as close as possible, making the Earth seem perfectly round when seen from a distance. A portion of the core's thermal energy is transported toward the crust by mantle plumes. These plumes can produce hotspots and flood basalts. A hotspot is an area of persistent volcanic activity. Hotspots originate at unusually hot areas of the mantle core boundary. Overlying mantle melts forming plumes of magma that rise and penetrate the Earth's crust, forming volcanoes. Hawaii, Iceland, and Yellowstone are excellent examples of hotspots. Hotspots are generally characterized by large outpourings of basaltic lava for relatively long periods of time. A flood basalt is the end result of a massive volcanic eruption or series of small eruptions that cover large stretches of land with basalt lava. Flood basalts have occurred on continental scales in prehistory, creating great plateaus and mountain ranges that we see in present-day Earth. The surface covered by one eruption can vary from around 200,000 kilometers squared to 1,500,000 kilometers squared. The thickness can vary from 2,000 meters to 12,000 meters. These are smaller than the original volumes due to erosion. Chapter 4, Erosion and Weathering. Erosion is the removal of solids in the natural environment. It usually occurs due to transportation by wind, water, or ice, by downslope creep of soil and other material under the force of gravity, or by living organisms such as burrowing animals in the case of bioerosion. Erosion shapes many things, such as the well-known Grand Canyon, along with many other valleys and beautiful structures. Weathering is the decomposition of Earth's rocks, soils, and their minerals through direct contact with the planet's atmosphere. 2 important classifications of weathering processes exist: physical and chemical weathering. Mechanical or physical weathering involves the breakdown of rocks and soils through direct contact with atmospheric conditions, such as heat, water, ice, and pressure. The second classification, chemical weathering, involves the direct effect of atmospheric chemicals or biologically produced chemicals in the breakdown of rocks, soils, and minerals. This video was created to help expand your knowledge of the processes that move and shape Earth's surface.